friends, so today we are working on lesson 23, which is that we can explain equivalence by manipulating the units and reasoning about their size. So we're going to be looking at equivalent fractions. Now remember, equivalent means that there are two different fractions that have the exact same value. All right, so let's go ahead and get started with our sprint. All right, so you should have sprint 23 there in front of you. And so what you're going to do is you're going to time yourself for 1 minute. You're going to pause the video before you hit go, time yourself for 1 minute, and then we'll go over the answers, okay? So go ahead and pause me now. All right, so you should have paused me, gotten your sprint done. So let's go ahead and check the answers, and you check off the ones that you got correct by yourself the first time. Ready? Number 1, 6, 2, 7, 3, 8, 9, 10, 10, 9, 8, 7, 6, 21, 31, 41, 51, 61, 91, 12, 22, 32, 42, 52, 82, 13, 23, 33, 43, 53, 83, 14, 24, 34, 44, 54, 84, 15, 25, 35, 45, 95, 81, 62, 83, 94, and 105. All right, so count up how many you got correct by yourself and write that number. And then let's get ready to head over for sprint side B. All right, so just like on the last one, you are going to put me on pause, time yourself for 1 minute, and then we'll go over the answers, okay? Get going. All right, so you should have paused yourself and gotten that sprint side B done, so let's go ahead and check it together, okay? Number 1, 6, 2, 7, 3, 8, 4, 9, 5, 10, 6, 10, 9, 8, 7, 6, 11, 21, 31, 41, 51, 81, 12, 22, 32, 42, 52, 92, other column, 13, 23, 33, 43, 53, 73, 14, 24, 34, 44, 54, 94, 15, 25, 35, 45, 85. All right, and then at number 40 is 61. Number 41 is 82. Number 42 is 63. Number 43 is 104. And number 44 is 95. All right, so go ahead and count the total number that you got correct and your improvement number. Did you get faster on the second time? Go ahead and count both of those numbers up. And then let's go ahead and get started on our warm-up. Okay, we're going to play a recognize the fraction game. So this equals 1 whole. On your personal whiteboard, write the fraction. So we have the 1 whole. If we have 3 equal parts, we call it 3/3. Okay, what is this fraction called? 6/3. Okay, now keep counting by thirds again. So the fraction we have is 9/3. Good job. Ooh, now what about this one? How many thirds are there now? 7/3. All right. What is the fraction shown here? 4/4 is correct. Okay, how many fourths are there now? 8/4. Good job. And that's the same as 2 wholes because we have 2 wholes completely shaded. Okay, how many fourths are there now? 12/4. And how many fourths now? 9/4. All right. What fraction is shown in this picture? This one shows us 6/5 because 1 whole is 5 parts, which are fifths, and we have 6 of them shaded, so 6/5. All right, what about this one? 9/8. And notice on all of those, when we did it, that they were all greater than 1. So that's why our numerator was bigger than the denominator. The number on the top was bigger because we had numbers that were greater than 1 whole. Anytime we get bigger than 1 whole, that's the only time we let the numerator be bigger than our denominator. All right, so now what we are going to do is we're going to work on our concept development. So if you have this paper in your packet, which you should, let's go ahead and turn to that page so we can get started on that concept development together. All right, so the first thing that we are going to do is we are going to split up each of these wholes into 3 equal parts. So go ahead and do that now on your paper. All right, now what I want you to do next is I want you to, how we have those thirds in our pictures, I also want you to take your number lines and split those up into thirds also, just like this. So now that we can see in this picture, we have a whole that's split up into thirds in the picture, and then we have the same thing on the number line. 1 whole on a number line that's also split up into thirds or 3 equal pieces. So what we're going to do now is let's go ahead and shade in 1/3. Ready? Shade. All right. And then what we're going to do is we're going to represent the same thing on the number line. So I have 1/3 in my picture, and I have 1/3 on the number line now. All right. So now what we're going to do is we want to make an equivalent fraction. Now remember, if they are equivalent, it means that they are 2 different fractions that represent the same value. So on a picture, it means that they're going to take up the exact same amount of space, and on a number line, it means they're going to be on the exact same spot on the number line. So the first thing that we want to do in order to do this is we're going to go ahead and break our next whole. We're going to split it in half. Ready? All right, so now we have broken that third into a new kind of fraction, which is the 6th, right? So let's go ahead and do the same thing on the number line, just how we broke our third into 6 by cutting the third in half. We're going to do the same thing on the number line. We're going to cut each of those thirds into half. So cut, cut, cut. And so now we have 6. So remember how we said before is that they have to take up the same amount of space or be at the same spot on the number line in order for them to be called equivalent fractions. So let's go ahead and shade in the same amount that we see from that first picture. Ready? Shade. Okay, so now when they're shaded though, I have a new fraction. What fraction is shaded now? Good job. It's 2/6, right? So we want to show that also on the number line. And I see that this is broken up into 6, so I'm going to count over to 2/6. 1/6, 2/6, and label it. You want to always make sure that you label. So like we said before, an equivalent fraction, 2 different fractions that have the same value. We see in the picture they have the same value because they're taking up the same amount of space. On our number line, we can also see that they have the same value and that they're equivalent because they are on the exact same spot on the number line. All right, so what we're going to do now is we are going to make another kind of equivalent fraction, just like how we split the third into halves in order to make 6. This time we're going to split each third into thirds. So let's go ahead and split those thirds into thirds. Ready? Let's do it. Okay, and then what we're going to do now is just like we split our picture into nines by making a third into a third, we're going to do the same thing on the number line. So we're going to take each third on that number line and we're going to break it apart into 3 equal pieces for each of those thirds, okay? There we go. Now, just like we did on our 2/6, we're going to shade in the exact same amount so that we can make an equivalent fraction. So let's go ahead and shade that in. All right, now what is the new equivalent fraction that I just made? 3/9. So I have 3/9 in my pictorial model, and I can also show 3/9 on the number line, and we notice that all of them are going to be lined up perfectly to show us that those are all equivalent fractions. Now, think about this for a second. Do you see any other equivalent fractions on the number line? Which ones are they? Yes, 2/3, 4/6, and 6/9 are all equivalent fractions as well because they all fall in the exact same spot on the number line. And if we are using our quick equivalent method, we can also know their equivalent because it skip counts by the numerator 2, 4, 6, and then it skip counts by the denominator 3, 6, 9. Okay, now you don't have to draw this on your board unless you have a whiteboard with you, but we're going to make an equivalent fraction with the same picture. So right now I see 1/4, but I can make a new equivalent fraction by taking that picture and taking each of those fourths and cutting them into half, just like that. Now, once I cut it into half, I have eighths. How many eighths are equivalent to 1/4? 2/8. Awesome. All right, let's try another one. What is the fraction that you see on this picture? 1/3. Okay, now just like we did before, we're going to take each of the individual parts and we're going to cut it in half to make an equivalent fraction. So I'll cut this one in half, cut that buddy in half, and he's cut in half too. What's the new fraction that we see? 2/6. And just like we've learned before, we can use quick equivalents 1, 2, 3, 6 to make those equivalent fractions. All right, so let's go over to your problem set. The instruction says, use the pictures to model equivalent fractions, fill in the blanks, and answer the questions. So first thing that we want to do is find 4/6 is equal to how many thirds. So let's go ahead and shade in 4/6. Okay, now remember, if they're equivalent, they have to take up the same amount of space. So I'm going to shade in that same amount of space on the picture. So let's shade it in. So when we first did it, it wasn't quite there. So I had to keep shading in order for them to be equivalent. Now, of those thirds, how many did I have to shade in order for them to take up the same amount of space? Yeah, 2/3. So we can say that 4/6 is equivalent to 2/3, and we can write that as a fraction to show the same thing. All right, now remember, using quick equivalents, we can go up, but we can also go backwards in order to simplify a fraction as well. So let's go ahead and go to our questions. It says, what happened to the size of the equal parts when there were fewer parts? What was happening? Yeah, the fewer the parts there were, the bigger each of the individual parts was. All right, what was happening to the number of the equal parts when the equal parts became larger? The larger the parts, the less parts there were. So when we had those big pieces, like for the thirds, we only had 3 of them, right? Instead of having more pieces, remember, if the pieces are bigger, that means the denominator is smaller. And if the denominator is bigger, then that means that the pieces are smaller, right? Because if we have a whole, the more times we break it apart, the smaller each piece becomes. Right, so you're going to use what we've gone through today and my help there on the problem set to go ahead and answer the rest of the questions. If you have any questions, please feel free to reach out to me, and I'd love seeing you at my Zoom lessons. All right, remember, Mondays and Wednesdays at 1 o'clock to 2 o'clock. All right, love you guys. Bye.